Problem 29, consider this limit where a is an unspecified constant. So we have the limit as x goes to -3 of x squared minus a over x cubed plus x squared minus 6x. The first thing to realize here, is that when we plug in x equal to -3 into the denominator, we get -3 cubed plus -3 squared minus 6 times -3. And this is -27 plus 9 plus 18, and we get 0. So when we try to plug in -3 into the denominator, we get 0. So if we want the limit to exist, part A says find the value of a for which this limit exists. If we want the limit to exist, we need the numerator to equal 0 and we plug in -3. Otherwise, we're toast. Like if we plug in -3 into the numerator and get 7, we'd be stuck with 7 over 0. The limit's not going to exist. So we need the numerator, plugging in -3 into the numerator, -3 squared minus a is 9 minus a, and we want this to equal 0. When does this equal 0? When a is equal to 9. So for part A of problem 29, for what value a does this limit exist? A is equal to 9. Okay, so now we have this patched up. This is the limit that we need to evaluate. The limit is x goes to 3 of x squared minus 9 over x cubed plus x squared minus 6x. Now our next goal is we need to manipulate the thing we're taking the limit of. In order to try to cancel things out, we're going to do that by factoring. The numerator is going to factor x squared minus 9, factors at x minus 3 times x plus 3. For the denominator, let's just check this real quick. I see that x cubed, x squared minus 6x, we can factor out x from the denominator to get x times x squared plus x minus 6. Now we need to factor this expression, and this is going to factor it as x plus 3 times x minus 2. So we have x times x plus 3 times x minus 2. The limit as x goes to -3 of this expression. And what cancels? The x plus 3's cancel. So this is the limit as x goes to -3 of x minus 3 over x times x minus 2. When we plug in -3 in for here, now this is allowed. -3 minus 3 over -3 times -3 minus 2. -6 upstairs, -3 times -5 is 15 downstairs. Looks like -2 or 5 to me. So yeah, that was a nice little clever problem. Think about what a had to be to make sure that this limit exists, given that you know the denominator is 0 when you plug in x is -3. Okay, problem number 30, another limit problem here. The limit as x goes to 5 of 25 minus x squared over x minus 5. When we plug in 5 upstairs, we get 25 minus 25, that's 0. We plug in 5 downstairs, 5 minus 5, that's also 0. Okay, so 0 over 0, we need to factor. The numerator factors as 5 minus x times 5 plus x. All that over x minus 5. Okay, so far so good. Now, the last little key realization we need to realize here is that 5 minus x and x minus 5 are negatives of each other. So instead of writing x minus 5, we could write negative 5 minus x here, because x minus 5 is equal to negative of times the quantity, 5 minus x, And now those cancel. And what do we have? The limit is x goes to 5 of 5 plus x over negative 1. And this is a case where you can simply plug in x is equal to 5 to get 10 over negative 1 is negative 10. Okay, so let's call that a wrap on this video.